Hey guys, welcome to another video. I'm your tutor Roland and we'll be doing another video. We'll be doing the number system for grade 9. In this video, we'll be looking at the real numbers. The real numbers are represented by an R with an extra line. We then have the irrational number set. This is represented by a Q with an apostrophe. These are non-terminating numbers like the square root of 5, minus 2 to the square root of 3, the answer pi, which we know is like 3.142, continuing, pi plus 5, 3 pi, pi over 4, anything pretty much that includes pi and anything that doesn't terminate, so any number that doesn't, end. So for instance, like a 2.7321 with a dot on top means that the 1 will keep on going forever, and like I've got here, I've got 1, 2, both of which have dots on top, and the 3 dots represents the fact that it will keep on going and never terminate. Alright, besides that, we then have the rational set of numbers, and these are terminating. So we have the Q with an apostrophe. For irrational, the irrationals have no apostrophe. We have numbers like 2 3/4, so that would be 2.75, and that is terminating. We have other numbers like 2.0, 3.173. As long as the number is terminating, you're good to go for rational numbers. We can look at numbers like 0.4, recurring, minus 100 over 7. So basically the 0.4 just means 0.44 and it terminates. If you've got minus 100 over 7, you'll have half, which is 0.5, and as I mentioned the previous numbers as before. The next is the set of integers. Now the integers are numbers from the negative whole numbers, including 0, and all positive numbers. We have numbers like minus 7, minus 4, minus 1, 3, 7, 2, 0, etc., etc., Besides that, we now move on to the whole numbers. Whole numbers are represented by an N0, and whole numbers are all numbers, including 0, that are positive, as long as they are whole numbers like 1, 3, 100, 10, 20, etc., but they also include the 0. Now then you have the natural numbers. These are all whole numbers, but except for 0. So you've got 1, 2, 4, and 7. Okay, just to recap, you've got the irrationals. We're going to highlight these in blue. So these are non-terminating numbers. You then have the rational numbers. We're going to highlight those in green. These are all terminating. You then have integers in yellow. These are all whole numbers, including 0 and the negatives. Then you've got the whole numbers, which include 0 and no negatives, and naturals, all whole numbers with no negative and no 0. All right, let's complete the following table. We now know all of our rules, so let's try out the numbers like 0, square root of 7, pi. Let's be honest, we already know what pi is. That is an irrational represented by the Q apostrophe. We then have minus 2 over 3, 0.73 recurring, 1.2357 with 3 dots, pi over 3 pi. Notice that you've got a pi on top and a pi on the bottom. 3 over 0, and square root of minus 16 with the cube root of minus 8. So our first column will be the natural numbers. These are all numbers that are whole and they are counting, which means they do not have 0. Whole numbers include the 0, the same as natural, but they have the 0. Integers are the same as the wholes, but they have negative whole numbers. Rationals are the same as integers, but they have decimals and they terminate. Then the irrationals are non-terminating. And real numbers are generally numbers that are not the square root of negatives or decimals, or a fraction, more like, where you've got a denominator of 0. Okay, with that said, let's look at the number 0. We'll highlight in blue and we'll do our ticks in blue as well. Is 0 a real number? And of course, it is a real number. Is it terminating? Yes, therefore it's not irrational. It means that it's rational. Is it an integer? Well, yes it is. Is it a whole number? Yes, it is. And is it natural? No, because you do not count with 0. You only count 1 apple, 2 apples, 3 apples, etc. After this, let's do the square root of 7. Is it a real number? Well, yeah, 100%. It's not negative underneath the square root. Is it terminating? No. Because what is the square root of 7? It's definitely not terminating. Let's look at pi. So basically, we know that pi is real and it's non-terminating. 7, put into your calculator with the square root sign, and you'll see it's non-terminating as well. Now, minus 2 over 3. Is it real? 100%. Is it irrational? Perhaps. But it's definitely terminating, okay? So you've got 0.66. Is it an integer? No. And if it's not an integer, it can't be a whole and a natural. So let's do 0.73. That is somewhat recurring, so 0.733. Is it real? 100%. Is it terminating? Yes. Is it an integer? No. And if it's not an integer, it's not a whole and it's not a natural. Now we've got 1.2357 with the 3 dots, meaning that it's continually repeating itself. It's real and it's non-terminating. If it's non-terminating, can't be any of the other 4 on the left to it. So now we've got pi over 3 pi. The pi and pi cancel, leaving us 1 over 3. Now, is 1 over 3 a real number? Definitely is. Is it irrational? Yeah. So if it's irrational, it can't be any of the 4 to the left of it. 3 over 0, this is the next one in yellow. Is it real? Most certainly not, because anything over 0 is imaginary. So we'll put a line through it. Now let's do the square root of minus 16. Can you have the square root of a negative number for a real number? Nope. So therefore the square root of minus 16, we'll do that in red, and we'll do the same as we did above. We'll draw a line right the way through and say that it is non-real. Now, this is going to be something that might catch you out if you're not aware of it. The cube root of minus 8 is actually minus 2, because minus 2 times minus 2 is positive 4, times by minus 2 is naturally minus 8. Is it real? 100%. Look at that, I'll put the minus 2 there for you. So it's definitely real. It's also terminating. Is it an integer? Yep. Is it a whole number? No. Easy game.